Welcome to chemistry class with Anekwe Ejike, your teacher. And in this particular video, we'll be looking at a very important topic in chemistry. And we'll be beginning immediately. But remember, if you're not subscribed to this channel, if you are watching this video class in YouTube, do well to subscribe by clicking the red icon on your screen now. All right, the topic for this particular video class is what? Separation techniques. Separation techniques. The method we use to separate mixtures. We use separation techniques. We want to look at them, and by the end of this particular class, should be able to define what mixture is and list at least 5 types of separation techniques, techniques of mixture and their uses. You should be able to list at least 5 separation techniques and their uses. So these are the things we want to achieve by the end of this particular video. And we'll be beginning with, first of all, looking at what mixture is. Because what we separate with separation techniques is mixture, not compound, not element. So we don't separate compound with physical mix. Rather, we break it through chemical mix. All right, a mixture contains 2 or more constituents which can easily be separated by physical methods. Mixture contains is combination of 2 or more constituents which can be separated by chemical means. Of course, compound contains 2 or more elements, but chemically bonded together, and it cannot be separated by physical means. But mixture can be separated by physical means. All right, that is it. And the constituents of mixture can be elements, it can be compounds, or it could be both. Mixture of compounds and elements, or it could be element, it could be compounds. All right, so that is the thing you need to note about it. Now, but a compound is a mixture, is combination of 2 elements. It's 2 elements or more elements but joined together in chemical method and cannot be separated by physical mix. Okay, now separation of mixtures. Most substances are not pure. They are mixtures of compounds or elements. To study the process or their properties of the substance, a chemist must make sure that the substance is pure. Now, the constituents of the mixture are not chemically combined or bound. Therefore, they can be separated by a physical method. I've said it before. What is being chemically joined together or combined together is compound. But mixture is not being combined chemically together. All right. Therefore, there are different ways or methods by which we can separate pure substances from mixture. Okay, number 1, we need to note the types of separation techniques. We are going to divide them based on the nature of mixture they are. Number 1 is separating a mixture of 2 solids. When 2 solids are being mixed together, 2 different solids are being mixed together, we have different method techniques to separate them. So I group them based on the nature of the substances that are being mixed together. So we have what we call one of the separation techniques as sieving. Sieving method, sieve, the way we use sieve at home. So this is a method we use sieve to separate 2 solids that have different size. All right, this is the method we use to separate a mixture of 2 solids of different sizes. Different sizes. Some of us use it in our houses. A sieve such as used for sieving floor has very tiny holes. Coarse particles are separated or broken up by grinding against one another, and the screen opening. What we are just trying to say here is this. When 2 substances that are of different sizes are being mixed together, sometimes even in our floor, we sieve it to sieve out the large particles that are not floor particles, maybe dust particles or sand particles that are there. We know that they are all solid, but they are of different size. So we can use sieve to sieve it away. You can see in this picture, this person is sieving, and this is another sieve. You can sieve in this method. The larger particles that are not needed will be on this, one, which will be on top, the residue. Then what you need will go down in the container and you use for. So we can use that to separate two substances that you need. All right, the other one that down now will now be the pure one that you need for whatever thing you need it for. Another method to separate two solids again is magnetic separation. Sieving separation, we have talked about it. One of the ways to separate two solids. This one is magnetic separation. How? You can bring iron filings and the sulfur. Two of them, they are all solid. You mix them together. And when you mix them together, you have something like this. Sulfur, iron filings, mix them together, they will be less. When you bring a magnet near it, the magnet will select all the iron filings there, to select them out, the magnet on it, and the sulfur will remain there. Sulfur is not magnetic, while iron filings are magnetic. All right, so with that, you can still separate them. Next one is sieving sublimation. Sublimation, solid which sublimes are separated from other solids that don't sublime or do not sublime, So they will turn directly. What we mean by sublimation is a substance that can change directly from solid to gaseous, to gas. We call it, if it's been mixed together with other solids, that one that sublimes, we can sublimes, it will evaporate, it will go from that solid state to vapor, and it will escape, and the other one will remain there. Something like ammonium chloride, camphor, iodine crystal, and a solid carbon dioxide. That means dry ice. These ones, they sublimes. When they are being mixed together with another substance that does not sublime, it can sublime. All right, you can see iodine crystal here, a mixture of iodine with sand. The iodine crystal will evaporate, it will sublime. You can see the subliming particle here, while the sand will remain. These are the ways in which we can separate these two solids. Another number two, of course, you say I grouped them, but we have discussed three separation techniques already. We have discussed sieving, we have discussed what again, the magnetic separation, we have discussed sublimation. It's also a separation method, separation techniques or method. Another one is decantation, but decantation is a method of is in the separating a solid, is in the group of separating a solid of an insoluble solid, separating a mixture of an insoluble solid and a liquid. A liquid and a solute, which is a solid that is not soluble in water. When you decant it, decantation, that solute, that solute will remain when solvent is being poured out. So the mixture, decantation is how do we do it? The mixture is allowed to stand for some time until it separates into two distinct layers. And in the upper layer, which is clear water, clear liquid layer, the solute beneath and the clear solution, upper layer of the liquid will be on top. Then the clear liquid can now be carefully poured and decanted into a second container. As you can see it here, this is the solute. This is a solid that is not soluble in a solvent, and this is the solvent. It's on top. You can just decant it. Decant it is pouring out this liquid. At the end, you get this thing back. It's the mixture of insoluble solid and solution of insoluble solid and liquid. Separation of the two is what we call, we can use decantation as one of the methods. Another one we can use also centrifugation. Centrifugation as another method we can also use to separate that. This one involves the use of what? Centrifuge, to separate solid particles from a liquid as is shown below. And as the centrifuge, this particular thing, yes, as the centrifuge spins, as it rotates, that means as it spins, the mixture of the solid separates and settles at the bottom, just like the other one we show in the test tube, while the liquid will be on the top layer. With that, you can now decant it again the way we did. It has been separated. This is it. You decant as it spines, the solid goes down, and you get what you want there. All right. The next one you can also do is filtration. This filtration is common in the lab. We do it in the lab, and with that, you separate the solid from the liquid. As you can see, this is beaker. This is the solid. The liquid one will be filtered off, and we'll use filter paper to put it here. Use filter paper to put it here, and the filtrate. This is now the filtrate, and the remaining here at the end of it, we will call it residue. This is now the filter funnel. This is filter funnel, and the remaining whitish thing that will be here is the residue, which is the chalk that was suspended initially in a solution, in a liquid compound. All right. Another way another group is separating a soluble solid from a liquid. This time around, is soluble liquid solids. This particular solid is soluble in a liquid, and we can still separate it. Though it's soluble in water, but we can separate it either in water or in any solvent. So one of the ways in which you can do that, another separation technique now is evaporation techniques or method. Separation method is something as separation techniques. So we have discussed many of them. This one is evaporation. Evaporation has to do with heating. You get a solvent, something like maybe sodium chloride or anything, you put it in the water or in a solvent, it dissolves. When it dissolves, when you heat it, evaporation, the water solvent will be going off. Water will be going off more. And the particular substance will now be at the end, like if it is salt that you are heating, at the end, the salt will be at the end of your pot. That is it. What is remaining will be at the end of your pot while the water will go off, though it takes time. So evaporation method is not suitable for salt that can easily be destroyed by heating. So any salt that can easily be destroyed as heating goes on cannot be used for needs. All right, another method for separation is what we call crystallization. Crystallization is the method used to separate salts which decompose easily on heating from their solution. All right, evaporation, we don't use such salt, but such salt that can decompose when heating is we use what we call crystallization method to do that. How is it being done? The salt solution, which is a mixture, is heated to drive away some of the liquid, of course. That means to evaporate the liquid until solution becomes concentrated or saturated. Of course, since it's soluble in water or in that solvent, as the heating goes on, there will be an evaporation, of course. And as it's getting evaporated, the solution gets concentrated. Now, the concentrated solution remaining is allowed to cool slowly, resulting in the formation of a crystals. And the crystal formation can be introduced by adding crystals of same sort to serve as a seed, or by scratching the inside of the vessel containing the solution. So after heating, after some part of it has been evaporated, you can bring it down. Of course, it's not concentrated, can bring it down, allow it to cool, and as it cools, it will crystallize. By crystallizing, we can do that by maybe adding more of that particular solute on it, and such thing will happen. This is what we mean. This is heat soluble solid in solution. You heat it, and as it's being heated, some part of it will be filtered off, crystallized, crystals of solid soluble salt. That is what we have at the end. All right, note, if all the liquid is evaporated, a powder will be obtained and not crystals. If all the liquid is being evaporated, this powder might also contain impurities, which otherwise will have remained in the solution and not contaminate the crystals. All right, many crystals form on cooling saturated solution contain water, which is chemically combined and loosely bounded to the crystal. We call it what? Water of crystallization. That is where we have the word of water of crystallization. And these particular salts, which contain water of crystallizations, are said to be hydrated. So any water that contains water of crystallization, we call it hydrated salt, which they are not anhydrous. Those that do not contain water of crystallization, we call them anhydrous. But this one that is being gotten through crystallization process contains water of crystallization, and they are hydrated salts. Okay, fractional distillation. Fractional distillation is a method used to separate a mixture containing different soluble solids in a liquid. Soluble, we are still in the third phase, which is soluble solid in a liquid. Now, when we have several solids that are soluble in a liquid, now fractional distillation is being used, and the solubility of different solutes and a given solvent must differ at different temperature. The process of the separation is known as crystallization process. While cooling the solution crystals of the relevant solid solute will come out of the solution, leaving behind the other, which are still within their limit of solubility. Now, another one is precipitation. These are separation techniques. This method is used to separate a solid which has a difference that are different in their solubility and two different miscible liquids. For example, ethanol and water are two miscible liquids. Ethanol is a liquid. Water is a liquid. Two of them, they are miscible. Now, to separate them, we use this particular method. Now, how do we go about this? Example, iron 2 tetraoxosulfate 6 acid, iron 2 tetraoxosulfate 6 is soluble in water, but not in ethanol. On addition of ethanol to a solution containing a mixture of iron 2 tetraoxosulfate 6 and water, the iron 2 tetraoxosulfate 6 will be precipitated out, and it can be separated by filtration. So when two miscible liquids, but they have different solubility in different liquids, different substance, it can be done like this one we are talking about. Is miscible in water, but when ethanol is being added, it will be precipitated out. All right, precipitation can also be said to be a process whereby dissolved solid can be removed from a solution using a precipitating agent. That's what we mean. By using a precipitating agent, the techniques of precipitation can be employed to remove hardness of water or hardness in water, as well as to purify water. Here, the precipitating agent, something like lime, which is calcium hydroxide, is added in a sample of a hard water, which is a mixture, because hard water contains some calcium ion, and the solute, which is the solid, can then be settled at the bottom of the container as precipitating agent, and the solid particles which precipitate can then be removed by filtration. Some of the precipitating agents, of course, even in a local way, we use alum. When you add alum to filter some water to have some coagulate it will precipitate it, and the particles will settle down, and the clear water will be up. With that, it will not be filtered up. So adding precipitating agent to such a miscible liquid will help out to precipitate the particular object or substance you want. All right, in the purification of an impure water using alum, of course, I talked about it. In a piece of an impure water using alum, a piece of alum, which is potassium aluminum tetraoxosulfate 6, is added to an impure water, the impurity immediately are precipitated at the bottom of the container. Clear water will be left on top of it. It's common. We use them in our homes. And when such is being done, you can do filtration, you filter. Now, the next one now is separating a liquid from a solution. Liquid now from a solution. That means actually impure liquid, let me use that word, is very, very soluble. Everything is just solution. But to separate that impure substance, impure liquid, or impure solution, how do? We use another separation techniques. Separation techniques we call distillation method. Distillation method is the evaporation of water or other liquid from a solution and its recovering on a pure state by condensation. Of course, when heating is being done, it evaporates, but that evaporation will condense using light big condenser to get it collected. So that gaseous liquid that will be evaporating will be condensed using an instrument. So the method of distillation is used to recover a solvent liquid from its solution. Now this a pure liquid now from this impure liquid, from other impure solid, whatever that is being collected from that evaporated water or solution is called a pure solution or a pure liquid. The apparatus used is shown below. As I said, when this is being heated, it passes through this is light big condenser, water condenser, or light big condenser. As it condenses, it's being collected here. It's being collected here, and if you want to freeze it, you can freeze it. Here, but it's not here. It's just as it comes down. As it comes down as a vapor, it reduces it because of the cool temperature here, and it turns it into water. So the particles now, impurities will remain here, but the water vapor, the cleared water will be here. This is just a thermometer to measure the temperature. All right. Distillation now. What is that difference between the distillation process and the evaporation process? Because two of them has to do with evaporation, but distillations are mainly for obtaining the solvent, while that of the evaporation for obtaining salts from solution. Now, in evaporation, what we want is at the end we get the solute, the substance that will remain at the end of evaporation. But that of the distillation, we are concerned with getting that vapor. All right. While here, which is distillation, it involves boiling and condensing, but evaporation involves only boiling. Only. It could be by heating. It could not be even by heating. When you expose any liquid in the atmosphere, it will have some level of evaporation there, and when sun gets harder, it gets evaporated. So it has to do with only heating, while that of the distillation does not involve only heating. It involves both heating and condensing the heated vapor. All right, separation of mixture of two more liquids. When we separate miscible liquids, how can we separate them? We use what we call fractional distillation. And this is what we use in the petroleum fraction of petroleum products. So fractional distillation is the process used in separating mixtures of miscible liquid by repeated evaporation and condensation, making use of fractionating tower or column, which we use in the industries. All right, the mixture of the two or more miscible liquids are separated into its component parts based on their boiling points. The liquid distilled according to their boiling point. The major thing here is that because they have their different boiling points, and the one at the lowest boiling point will evaporate at the top. Those that have higher boiling point will be at the below. So the apparatus used is what we have here. So we can also, this is fractionating column. We can also use this. All right, the next one is the separating immiscible. This one is immiscible. The other one is miscible. Immiscible liquids using separating funnels. Now, or separating method. This is This method used to separate a mixture of immiscible liquids. Example, a mixture of petrol and water. Petrol and water, they are not miscible. They are all liquid, but they are not miscible. When the two liquids that are added together, they do not mix. We call them immiscible. Instead, they separate out on the distillate layer. A lower one will be the one that is heavier. The one lesser will be on, denser one will be down. So that is what we have done so far. These are the different separation techniques we have done. And for further discussion and inquiry, do well to get to me through my phone line or phone contact, a WhatsApp line, as you can see it on this display on the screen, or you can send me email with using my email address at christo116@gmail.com. Thank you for being part of this particular class and remain blessed. Remember, if you have not subscribed to my channel, watching this thing in the YouTube, make sure you subscribe by pressing the red buttons in your screen, as you can see it now. Thank you for doing that. May God bless you.